So here is the review for the last summative, which is on Friday. Okay, so some of these questions are review questions that were on previous tests and previous units, and then some are from the new unit. Okay, so the first two are from previous units. These are work questions. So we have Jacob, we have Caitlin, and we have what they're doing together. So they're making puzzles over time. So Jacob can finish 2 puzzles in 12 minutes. Caitlin can do 5 puzzles in 17 minutes. And together, how long is it going to take them to do 11 puzzles? Okay, so before we've done this, so we're going to do it again. We're going to use the denominators in like a little chart. There we go. So what is 12 missing that 17 and x have? Well, they're missing 17. Oops, sorry. They're missing 17 and x. What is 17 missing? It's missing 12 and x. And x is missing 12 times 17, which is, let's read this out, 204. So what we're going to do is multiply that row there that we just made by the numerators of the original problem. So we got 17x here, 12x here, and 204 right there. Okay. When we multiply it out, we get 17 times 2 is 34x. 12, oops, sorry, that's the wrong thing. 12 times 5 is 60x. And 204 times 11 is 2,244. We combine the like terms to get us 94x is equal to 2244. And we divide both sides by 94 to solve for x. So x will equal 23 point, we'll round up to 9 hours. And there we go. Okay. Next question, we got Juan and Ava. So we're mowing lawns with Juan and Ava and together. So we're mowing lawns and the time it takes to do that. Okay, so Juan can do 7 lawns in 5 hours. Ava and Juan together can mow 11 lawns in 3 hours. How long would it take Ava by herself to mow 4 lawns? So there's the x. So just like last time, we're going to make our little table. We got 5, x, and 3. Okay, so 5 is missing 3 and x. X is missing 3 times 5, which is 15. And 3 is missing 5 and x. So we're going to multiply the numerators by what was missing. So we have 3x, we have 15, we have 5x. Okay. So we multiply the numerators by those red numbers. So we got 7 times 3x is 21x, plus 15 times 4 is 60, equals 5x times 11, which is 55x. We're going to subtract 21x from both sides to get all the x's on one side. So we have 60 equals 55 minus 21, which is 34x. Divide both sides by 34, and x will equal 1.8 hours. And there we go. That is it. All right, for the next set of questions, these are simply unit circle questions. These are like the equations that we had. There's not much solving to do because it's already solved for you. You just got to figure out what the radians are for this to find the answer. So again, we're looking for a unit circle, or at the unit circle between the radians of 0 and 2 pi right here. Okay, so it can only be 1 revolution around the unit circle. So if you remember from when we did this, the cosine values are x's in the points, and the sine values are the y values in the points. So if we're looking at sine of theta is equal to negative root 2 over 2, we're looking for any y value that is negative root 2 over 2 in the unit circle. There are 2 of them. All right, the first one is 5 pi over 4. The second one is, where is it? 7 pi over 4. And that is it. So you're just looking at the unit circle to find where negative root 2 over 2 is at the y value and figure out what the radian is, and then you're done. For cosine of theta is equal to negative root 3 over 2, there are again two of them. We're looking for the x value and the points, that is negative root 3 over 2. All right, so we have 5 pi over 6, and we have 7 pi over 6. For sine of 1/2, the y value that is 1/2, we have pi over 6, and we have 5 pi over 6. And lastly here, cosine is equal to negative 1. So where's the x going to be negative 1? There's only one of them this time. It is pi, and that is it. Okay? All right, now we're solving equations. These are review questions. All right, and the first one, you have 3x cubed minus 6x squared minus 24x. And in this case, there's something that they all have in common, and that is a 3x. So if we take 3x out, we're left with x squared minus 2x minus 8 equals 0. Okay, whatever's in the parentheses, we can now factor. So we're going to figure out what two numbers multiply to give you negative 8 and add up to give you negative 2. All right, those two numbers would be negative 4 and positive 2. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. The 3x is still in our problem, so we put it out in front. Now what we do is we take each one of these factors, the 3x, the x minus 4, and the x plus 2, and we set them all equal to 0 to solve them. When we do, these values give us our answer. So x equals 0, positive 4, and negative 2. So we solve them all for x. All right, and number 8, before we can solve this, we have to actually set it equal to 0 like the last question was. So in order to do this, we're going to subtract by 10 on both sides. All right, we will get 25x squared minus 1 is equal to 0. This becomes a difference of two squares problem, where everything in this problem is a perfect square. So 25, x squared, and 1 are all perfect squares. So the factors of this are going to be 5x and 5x to give you 25x squared. Then 1 times 1 to give you positive, or to give you 1 rather, and then 1 has to be positive and 1 has to be negative. So if we set both of these equal to 0, 5x plus 1 equals 0, and 5x minus 1 equals 0, we solve them both for x, and x will equal positive and negative 1/5. And we're done. If you want to write it as 1/5 and negative 1/5 separately, that's perfectly fine. Okay, number 9. Okay, this is a radical equation where you have a square root inside of our equation. In order to solve this, we want to get rid of that square root sign, but in order to do that, we have to get it by itself. And right now, it's not by itself because that 4 is out in front of it. So we're going to divide both sides by 4 to get rid of it. So those will cancel. So we get the square root of negative 9 plus 2x squared is equal to 12 divided by 4, which is 3. All right, now that our square root sign is all by itself on the left side of our equation, now we can get rid of it by squaring both sides of our equation. The square root and the square root will go away. We're left with negative 9 plus 2x squared equals 3 squared, which is 9. All right, now we solve for x squared. So we're going to add 9 to both sides. So we have 2x squared is equal to 18. Divide by 2, and x squared will equal 9. Now, in order to solve this, we have to square root both sides to get rid of that squared. Okay, so the square root and the square root will go away. We're left with x is equal to plus or minus 3. All right, as a quick reminder, when we did this kind of question in terms of the sine and cosine equations that we did, I think it was on Friday or Thursday, whatever day it was. All right, we square rooted both sides of the equation, you get a plus or minus. And that is because if you put plus 3 in for x, or positive 3 in for x and square it, you get 9. If you put negative 3 in for x and square it, you also get 9. So there are two possible answers. Okay, technically you should check these. When you put in positive 3, you'll get, for x, you'll get 3 squared is 9, times 2 is 18. Negative 9 plus 18 is positive 9. The square root of 9 is 3, and 3 times 4 is 12. If you put negative 3 in there as well, again, negative 3 squared, well, again, gives you positive 9. All right, 2 times 9 is, again, 18, and the same problem as before. So these both do work. All right. Number 10, this is already by itself, so we can just go ahead and start by squaring both sides to get rid of the square root sign. We have negative 82x minus 1 is equal to 81. We add 1 to both sides to get the negative 82x by itself. And we divide by negative 82. So x will equal negative 1. Again, we should check this answer. If you put negative 1 back in for x, negative 82 times negative 1 is positive 82. 82 minus 1 is 81. And the square root of 81 is 9. So that does work. All right. Okay, number 11. So we're converting the radian measures to Eerie measures. So the conversion for this is you're going to multiply by 180 over pi. Okay, so what happens is the pi's cancel themselves out. You do 6 divided by 5 times 180 gives you 216 degrees. And that's it. So you can also do 6 times 180 and then divide it by 5, whatever you want to do. Just taking 6 over 5 and multiplying it by 180. All right, part B, same idea. You got 180 over pi. The pi's will cancel. You get 13 times 180 divided by 4, and that equals 585 degrees. And then lastly in this part is pi over 10 times 180 over pi. The pi's will cancel. So you have 1 over 10 times 180 is 180 divided by 10. Get 18 degrees. And that's it. Now, if you're going the opposite direction, if you're going degrees to radians, you're going to multiply by pi over 180. Okay, so now you have 320 divided by 180. That gives you a decimal. So you're going to hit math, enter, enter on your calculator, and you're going to get 16 pi over 9. You always write these radians as fractions. Okay. Now, if you're like, I don't have a calculator, Mr. Brady, because we're not in school, well, you should have the Calculate 84 app on your iPad to do these problems if you don't have a calculator handy. All right, next, you got 110 degrees times pi over 180. So 110 divided by 180 gives you a fraction of 0.6 blah, blah, blah. All right, then you hit math, enter, enter to give you a fraction. It gives you 11 pi over 18. And lastly, 50 degrees, you multiply by pi over 180. So you have 50 divided by 180 gives you another decimal. You're going to hit math, enter, enter, and you get 5 pi over 18. And that's it. That is your conversions. All right, so we have 3 functions below. Determine which one has a greater y-intercept. Circle the function as a greater value and show your work to justify your answer. Okay, so in order to figure this out, when you're doing the y-intercept, you're trying to find out where the graph or the equation crosses the y-axis. That is at where x is 0. So if x is 0, which is right here, the graph crosses here, which is at negative 5. So the y-intercept is negative 5 for the graph. Okay. Now, if we do this for g, we have 3 to the 0 power, because we're putting 0 in for x, minus 10. So if you're on your calculator, you go 3 to the 0 power, you will get 1. And 1 minus 10 is equal to negative 9. Well, negative 5 is bigger than negative 9 because it's a smaller negative number. All right, so we got one more to try. We have here, we put 0 plus 4, and then negative 5 out in front. So 0 plus 4 is 4, and the absolute value of 4 is also 4. So we have 4 times negative 5. And negative 5 times 4 is negative 20. Okay, so out of all of these, all right, this function has the greatest y-intercept. There we go. All right, let's see, here we go. All right, this is a little bit like the equations that we had above. You have the sine of 150 degrees. You want to look at your unit circle and look at 150. So we find 150 and figure out what the y value is for 150, and that is going to be 1/2. Okay. So in the equations above, we were finding the radians based off the points. This time we're using degrees or the radians to find the points. Okay, so for cosine of 4 pi over 3, so we look at 4 pi over 3 on our unit circle. This is cosine, so we're looking for the x term. The x term of the point at 4 pi over 3 is negative 1/2. And sine of 2 pi, so 2 pi is all the way around the unit circle. It's the same as 0 pi. Looking for the y value, and that is 0. And lastly, the cosine of 210. You know, 210, we're looking at the x term of 210 degrees, which is negative root 3 over 2. Okay. All right, match the equations to the graphs below. Okay, so for the first one, this is an exponential function, so it's y is equal to 3x, 3 to the x. All right, the next one, since it's starting at 0 and going up first, it is a cosine, or sorry, is a sine graph. Y equals the sine of x. All right, since this next one starts at 1, it is the cosine graph. And lastly, that is a cubed graph, so y equals x cubed. Okay. All right. So next, use the information on the unit circle to graph cosine of x over the interval of 0 to 2 pi. So we're going from 0 to 2 pi. If you're looking at cosine, you want to use the unit circle, you can use all of the values on the intercepts, or on the axes. So we start off at 1. Then we go down to 0 at pi over 2. At pi, we're at negative 1. At 3 pi over 2, we're back at 0. And at 2 pi, we're back at positive 1. So the graph should look like this. Beautiful. All right, the period of this graph is going to be 2 pi. It's 1 revolution around the unit circle. The minimum value is negative 1. The maximum is positive 1. The amplitude is 1. And the midline is y is equal to 0. Okay, remember your midline should be an equation of y equals something. Okay, here we go. Identify the list of characteristics for the function graph below. So let's start down here at the on the y-axis. So this starts there, it goes up to the top and then comes back down before it starts to repeat itself. And that's where it's going to end before it starts to repeat. So if we look at here, when it stops, it is at pi. That's the period. Okay, the minimum value, the lowest point on the graph, is negative 4. The maximum value, the highest point on the graph, is 2. The amplitude is the middle of the graph. From the middle to the top or middle to the bottom. Another way you can do this is find the total distance from the maximum to the minimum, which is a total of 6, and divide it by 2, which gives you 3. So that means your midline has to be right here at y is equal to negative 1. So from negative 1 to positive 2 is 3, and from negative 1 to negative 4 is also 3, and that is the amplitude. All right, and then we have our unit circle for reference down here. On the test, you'll be given one of these on the test so you can see it and use it to your advantage, because a lot of the answers to this test are actually from the unit circle directly. So, and from that, we wish you good luck on the test tomorrow, and